Rational inequalities are inequalities that contain one or more rational expressions. So it could be something like 1 over x plus 2 over x minus 3 is less than 4 over x plus 5, right? That's the idea here. What's going to be happening is, since it's an inequality, it's kind of hard to deal with when do we multiply by a negative or not, because sometimes x minus 3 is negative and sometimes it isn't. So what we do is we first thing we do, and this is step one, we have to find the excluded values, because those can't be an answers because they would make this undefined. And then we turn it into an equation and we solve the equation. Okay, so basically we get a list of excluded values, let's say like 0, 3, and negative 5, and then we solve it and we get x equals 4 or something like that. I don't know. I'm not actually solving that equation. I'm just making stuff up. Once we do that, we're going to use all of those values uh, to turn the number line into intervals. And what we mean by that is we're going to take a number line, 0, 1, 2, 3, 4, 5. And what we're going to do is we're going to chop it up into pieces. 0, 3, oh, negative 5 is way over here, and positive 4. So now you can see that there are 1, 2, 3, 4, 5 regions where solutions might exist. So then we just have to check each one of those regions to see if it makes the original inequality true or not. And it really, that's all it is we just have to test values in each of the intervals. Okay, you'll see what that looks like here in a second. Example 6. Solve a rational inequality. The first step is to find the excluded values. So when does x minus 2 equal 0? That equals 0 when x equals 2. So x cannot equal 2. Now I just set up the equation. That's exactly the same as my inequality, except I changed out the inequality sign for an equation. It looks like my greatest common denominator here is 12 times x minus 2. And I just did that by 3 times 4 times x minus 2. I know 3 and 4 don't have any common factors, so there's nothing to really reduce out there. So I have x times 12 times x minus 2 divided by 3 minus 1 times 12 times x minus 2 divided by x minus 2 equals x plus 1 times 12 times x minus 2 all over 4. And now we reduce things out. 3 goes into 12 4 times. X minus 2 goes away. 4 goes into 12 3 times. So I have 4x times x minus 2, or 4x squared minus 8x. Negative 1 times 12 is just negative 12 equals, well, this one's going to be a little bit more. I'm going to kind of do a little bit of scratch work up here. X plus 1 times x minus 2, and that whole thing is going to get multiplied by 3. So I have x squared minus 2x plus 1x minus 2. So I have 3 times x squared minus x minus 2, which comes down to 3x squared minus 3x minus 6. Now it's a quadratic, so I want it set equal to 0, so I'm going to subtract 3x squared from both sides. I'm going to add 3x to both sides, and I'm going to add 6 to both sides. So I have x squared minus 5x minus 6 equals 0. Let's go ahead and factor that. So the product is negative 6 and the sum is negative 5. How about -6, and +1. So x equals 6 and x equals -1 are my two solutions. And I'm going to remember this x equals 2, that's the excluded value. All right. And I'm going to rewrite the original here so I have it when I scroll down. Okay. So let's make a number line. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And that's okay. That's enough right there. So here is where I'm splitting it up. At x equals 2, draw a dotted line. At x equals 6, draw a dotted line. At x equals -1, draw a dotted line. You can see there are 4 regions that I'm investigating. Region 1, 2, 3, and 4. And what I'm going to do is I'm going to take a value from each one of those regions and plug it into my inequality and see what's true. For example, let's check -5. What is -5 over 3 minus 1 over -5 minus 2? Is that less than -5 plus 1 over 4? Well, -5 plus 1 over 4 is just -1. And here we've got -5 over 3 minus 1 over -7, or I guess since that's a minus a -7 there, I can make this plus 1/7. Common denominator 21, so 7 times 3 is 21. 7 times 5 is 35. 5 times 1 is 5. 35. Is that less? Oop, I don't want 5. I want 3. Sorry. I almost messed up my common denominators there. Negative 35 plus 3 is -32 over 21. Is that less than -1? Well, at this point, I just kind of care about the decimal approximation of it. I don't care if it comes out to be a nice round number. And I see it's -1.5 is less than, approximately, right? Is less than -1. So in this first region here, it worked. So I'm gonna be able to describe the solution using that. Now let's do some other ones here. 0, I'm checking from the second region now. 0 over 3 minus 1 over 0 minus 2. Is that less than 0 plus 1 over 4? So is 1/2 less than 1/4? No, it's not. 1/2 is not less than 1/4. So no solution there. And now I'm going to check a number from region 3. How about 2 is a nice round number. Oh, wait a second. I can't use 2. I drew my my dotted line in the wrong spot. Oh no, I did. That's at 2. My problem was the point I chose right there was actually supposed to be 3. Okay. So 3 over 3 minus 1 over 3 minus 2 is less than 3 plus 1 over 4. So 3 over 3 is 1 minus 1. Is that less than 1? Well, 0 is less than 1. It works out. Okay. Sorry, I should cross that out there. That's not true. One more to check. How about the point? Oh, we did 6 there. How about, well, how about 9? 6, 7, 8, 9. Let's do 9. That's the one we're going to check. The reason why I chose 9, and I should have chosen -6 when I did -5 before, is because I know 9 divided by 3 gets me a nice round number. So that's one less fraction I have to deal with. 1 over 9 minus 2 is less than 9 plus 1 over 4. So this is 3 minus 1/7. Is that less than 10 divided by 4? All I got to do is look at the decimal values of that. 10 divided by 4 is what? What is 10 divided by 4? 2.5. So is 3 minus 1 divided by 7 less than 2.5? And no, it's 2.6 and junk. 2.86 rounded. So no, this one is not true. So that means there's no solutions in there. So now what I've done is I've divided up my region into two sections that have solutions, not including -1, but everything less than it, not including 2, and not including 5, but everything in between it. So my solutions will be x less than -1 and 2 is less than x, which is less than 5. So it's a combination of those two things. Now, if you wanted to use interval notation, I would write -infinity to -1, not included, union 2 to 5. So that's another way you could write your solutions down for that problem. Either one of those work just fine.